Alright, I'm going to demonstrate a simplified method for solving a circuit. Solving a circuit meaning finding all of the unknown parameters, in this case the node voltages at VA, VB, and VDA. Of course, those are all the voltages with respect to ground, as usual for a node voltage. So the node voltage method is just KCL combined with Ohm's law. So in fact, it's called the voltage method, but it's actually currents. So the way you do this is at each node, you imagine that there's a current going out of the node. There are all these currents. But you don't actually write these currents as currents. You write these using Ohm's law. So for example, at node VA, we could call this node A. Typically you call it VA. This current on the left is just using Ohm's law, this voltage from here to here divided by the total resistance. So we have VA over 2R. Then this current here is the voltage across this resistor divided by the resistance. So we're summing the currents. We're assuming all of the currents going out are positive. So this is VA minus V0 over 2R, because the voltage here minus the voltage here, of course we're talking about voltages with respect to ground. Then this other current is VA minus VB divided by R. Sum of all the currents is 0. Now at VB, I start with VB minus VA over R. That's this current here. VB minus VA over R. Plus the middle one going down, VB minus V1 over 2R. Plus the one going to the right, VB, and I just noticed I'm doing all lowercase and those are capital, but you get the idea, minus VDA over R. Sum of all those currents at that node. Okay, so I want to show you something here. This current in the middle, that was this guy here. But notice this current, as I wrote it here when I did VA, this current here is this guy right here. So when I do the node VB, how would I write that current when I do node VB? Well, at node VB, I'm saying currents going out are positive. So this current going out, this current going out, those are positive. So this guy right here is this guy right here. Then this guy, I'm saying it's positive going out, VB minus VDA. This guy, since it's going in, I have to put a minus sign in front of it. And this current is this guy. So if I put a minus sign in front of that, then that's what I get right here. So you see, it doesn't matter which direction I put this current, the sign works itself out. Okay, so I also have to have node VDA, even though it's a non-essential node, meaning there's not 3 branches. There's only 2, but it's VDA is the value that we want to know. So we're labeling this node so that we can find out that value. I have VDA minus VB over R plus VDA minus V2 over 2R. I obviously don't have a current here because there's nowhere for the current to go. So sum of all the currents is equal to 0. Make some more room. I'm going to multiply everything by R to get rid of the R dependence and regroup all the unknowns with their coefficients. And finally, write this system of equations as a matrix equation. And this is how you would solve it in MATLAB. Note that your input vector is B, and this is the proper way of inverting a matrix in MATLAB.